Hello everyone, my name is Ömer Faruk Yigit. I'm a senior computer engineering student at Ankara University. Today, I will be presenting my final project. But before that, I would like to introduce myself. As I mentioned, I'm a student at Ankara University. Additionally, I have been working as a software developer for nearly 2 years at a startup focused on IoT and digital transformation. I choose the topic of my final project from a field that I am already familiar with and currently working on. If you'd like to learn more about the startup I work for, you can visit the website upu.io. Now, I can start presenting my final project. The topic of my final project is collecting electricity usage data in homes using IoT devices and processing this data to make it meaningful. Following this, the data is used alongside AI to provide suggestions and alerts to user, aiming to increase energy efficiency. Yes, here we can see the main topics of my presentation, which are in order: introduction, literature review, material and method, experiments, and conclusion. In the introduction section, I will try to share with you the problem definition and the aim of the project. In the literature review part, I will talk about the conclusions we can draw from the projects previously conducted in this field. In the material and method part, I will explain how the project will be carried out. And finally, I will touch on the experiment and conclusion parts and finish my presentation. Let's start with the introduction section. First, let me explain the problems we addressed in this project. Current energy management systems often fall short when it comes to predicting and optimizing energy consumption in real time. While smart home systems typically provide basic monitoring and control features, they lack actionable insights or forecasts for users. This results in unnecessary energy consumption and higher utility bills. The aim of the project is to tackle these issues and improve energy efficiency. By integrating IoT devices and machine learning models, we designed a system that not only predicts energy consumption but also optimizes it. Additionally, the system offers a user-friendly web-based interface for better accessibility. Let's move to the literature review part. In literature review part, I focused on examining the contributors of IoT and artificial intelligence research to energy efficiency. Findings from various studies indicate that the AI algorithms, such as regression models and clustering techniques, are highly effective for energy consumption prediction and optimization. However, many of these studies lack solutions tailored to individual users. In our project, we aim to address these shortcomings by developing a more personalized energy system. Let's move to the material and method part. First, let's start with the material section. This project includes two different approaches. One involves collecting data using ESP32 and sensors, and the other involves accessing data through to API outputs of a smart plug. If we choose to use ESP32, AWS IoT Core will be the ideal option for data communication. To analyze the collected data, we need to use various Python libraries. Another important point is the providing feedback to user. For this, we need to create a user-friendly dashboard using React.js. Now, moving to the method part, the collected data must be first cleaned and normalized. Various machine learning models should be then applied to the data. These includes linear regression for energy prediction and k-means for clustering, identifying user patterns. Of course, another topic I should mention is that we need to use the MQTT protocol for data communication. Now, let's proceed to the experiment section. At this stage of the project, no formal experiments have been conducted yet. However, the system's architecture have been designed and the technologies to be used have been identified. Data will be collected via ESP32 or smart plug integration, Machine learning models will be applied and the results will be displayed on the dashboard. In the future, the system will be tested in a real smart home environment. These tests will evaluate the accuracy of linear regression model for energy consumption prediction and the efficiency of k-means clustering algorithm in identifying user habits. Now, let's proceed to the conclusion section. In this project, we developed a system that combines IoT, artificial intelligence, and cloud computing technologies to predict energy consumption and enhance energy efficiency. The system collects real-time data through ESP32 or commercial smart plugs and makes predictions using linear regression. These predictions will help users make more informed energy usage decisions. Although the project is still in prototype stage, future updates will include integrating renewable energy systems, interactive features like real-time feedback, and ancient security measures. This will further expand the system's usability. These are the sources I use to gather information and conduct research. Thank you very much for listening and taking the time to attend my presentation.